Good day, my name is Duart Leroux. I'm the co-director of Purple Pepper Maths. Very exciting to help you today negotiating your way through the NBTs. We have here more than 20 lovely hand-picked math questions, and I'm going to take my time to help you working through these. They range from various modules in the grade 10 to 12 math syllabus, and as we do them, we will also touch on some of the skills that you were taught in grade 7, 8 and 9 that you still need, and the NBT examiner expects you to still be able to do those. What you see on the screen is on the right, on the left, the NBT Math Prep Tool, a very popular book. This is the cover of the book that we use here at Purple Pepper Maths, and then you also see a couple of other books that we use here at Purple Pepper. Lovely books, and I strongly suggest that after having done the videos with us here, that you consider purchasing one or two of these books to further cement your skills. We're going to start immediately with one of the questions that come from the books that you've just seen on the screen. And what you see here is a four-sided figure, and because of the two parallel sides, this four-sided figure is a trapezium. One pair of opposite sides are parallel. Because of the parallel sides and because of the right angle that you see there at the top, the angle at the bottom would also have to be a right angle. We call these angles co-interior angles, adding up to 180. And since the one angle is 90, the other angle would also be 90. We then continue by dropping a line perpendicularly from the top there to the opposite side. And just to quickly go back, remember that you can see here, it says that the area of the trapezium is 100. And so we're going to start by writing down the area of the trapezium. We're going to get back to that in a while, but let's go to the construction again. We have a construction, and the construction is from the top of the trapezium perpendicularly to the bottom, and we now sit with three right angles. And therefore, since three of the angles in the four-sided figure here on the left is 90, the fourth one would also be 90, since the four angles in a quadrilateral add up to 360 degrees. All right, now on the left, as you can see, we have a rectangle for 90 degrees. One dimension is x, the other dimension is 2, and therefore the area of this rectangle would be 2 times x, that is length times width, plus on the right we have a triangle, and the area of the triangle is such that if you go back to the bottom of the trapezium, you can see there that 7 is the dimension representing the bottom line of the trapezium. Now since that is 7, and we know that the opposite side of this blue rectangle is 2, that's 2 and 2, the opposite sides. Therefore, the triangle's dimension here at the bottom would be 5, because 5 plus 2 is 7. The angle is a right angle. We have an x as one of the dimensions of the blue rectangle, and therefore the opposite side is also x, and that is the height of the triangle. And so the area of the triangle would be a half times base, that is 5, times height, which is x, and therefore the area of the rectangle plus the area of the triangle is equal to 100. Now what we do is we're going to simply add those, and we have 2x plus a half of 5 is 2.5, so that is 2x plus 2.5x is equal to 100. If we add 2x to 2.5x, that gives us 4.5x. So 4.5x is equal to 100. We then divide by 4.5 on the left and on the right. So x is equal to 100 divided by 4.5. And you can see the answer right here at the bottom, D. Now consider the answer, 100 divided by 4.5. 100 divided by 4.5 is also 100 divided by 9 over 2. And what we now can do is we can continue to manipulate. I do this simply because the examiner can by default expect of you to do what I'm going to do now. So we can say, we can write 100 divided by 9 over 2 as 100 over 1, multiply by the reciprocal, which is 2 over 9. So remember, when we divide by a fraction, we multiply by the reciprocal of the fraction. And so that's what we are doing here. So we multiply 100 by 2 over 9. And that gives us 200 over 9. And so that fourth answer, D, could just as well have been 200 over 9 rather than 100 divided by 4.5. Now, if you consider 200 over 9, remember 200 over 9 means 9 dividing into 200. And so what the examiner can also expect of you is to know that 200 over 9 can be written as a decimal. 9 divides into 20 twice, because 2 times 9 is 20, leaving a remainder of 2. 9 divides into 20 twice, because 2 times 9 is 18, leaving a remainder of 2. 9 divides into 20 twice, and so forth. And eventually you can see that 22.2 recurring could also have been the answer. So that answer could have been in decimal form, in improper fraction form, or in this strange form that you see there. Let's move on to the next question. On the screen you can see there is a right angle triangle, triangle ABC, and what we're going to do is we're going to first take note of the right angle, and then also the fact that we have AB, which is given to be 13 units, and then we also have AC, which is 3. So the first thing that should come to mind is that we can use the theorem of Pythagoras to find the bottom side there, that is BC. And so we're going to start by saying BC squared is equal to 13 squared, which is 169, minus 5 squared, which is 25, and 169 minus 25 is 144. And therefore, BC is 12 units. That's the square root of 144. Now, what you see here on your screen is that this triangle, I'm going to make it blue, triangle ABC, we have the bottom side here, which is 12, and we have the 5, and those are such that they sit around the right angle, and so we can find the area of this triangle, although it wasn't asked. What you need to sometimes do is just to do what you can do, and that's what we're going to do here. And so we're going to find the area of this triangle ABC. And so the area of triangle ABC is a half times the base, which is 12, times the height, which is 5. A half times 12 is 6. 6 times 5 is 30. And there we have the area of the triangle. And yes, I know that wasn't asked. In fact, what we are actually looking for is the value of x, which is the length of this side here that you can see. There we go. I'm going to just try that again. There we go, that line there. And so to find x, what we're going to do is we're going to use the 30 squared centimeters, the area of the blue triangle ABC. And we're going to do that as follows. If you consider the triangle, I've just redrawn it for you. There you have AB, which is 13, and you have the x there, that is the length of that little line. Now, since this blue triangle ABC is such that we can also see AB as one of the bases of the triangle. We can use AB as the base, and we can use this line here as the height of the same blue triangle. Then we can say, since that is so, we can say a half times 13, now that's the base, times x, and that is the height, is the same area, which is 30. We then solve this triangle by equation by multiplying by 2 on the left, and by multiplying by 2 on the right, And in doing that, we get rid of the half. We then divide by 13 and we obtain the answer, which is 60 divided by 13. And you can see the answer sits right there. Well done. And we move on to the second video.